Welcome to ROAV Perfect classes. In this video, I will discuss most important previous year questions of chapter 1, 2, 3, 4 and 5. I will try to cover in one video all these questions. If I can't do it, then I will continue this series in next video. Now first chapter, that is real numbers. The first chapter, real number. In this chapter, the first question that is important, the decimal expansion of the rational numbers 43 over 2 raised to power 4 multiply 5 raised to power 3 will terminate after how many places of decimal? We have to find out. Terminate after how many places of decimal? For solving this question, you have to write first of all 43 over 2 raised to power 4 multiply 5 raised to power 3 as it. Then 43 over 2 raised to power 4 multiply by 5 by 3. Then here we take 5 raised to power 1 over 5 raised to power 1. It will convert into 43 multiplied by 5, 215 over 2 raised to power 4 multiply 5 raised to power 4. Now you can see 2 raised to 215 over 2 and 5's raised power is common, that is 4. 215 over 2 5's are 10. 10 raised to power 4. So we can say that its answer is it will terminate after 4 places of decimal. 4 places of decimal. Here we multiply 5 by 5 because we have to make here power equal. So that's why we take here 5 raised to power 1 over 5 raised to power 1. When we cut it, then it will reasonable value. Now second question, find the largest number that will divide 398, 436, 542, leaving remainder 7. For solving this question, first of all we have to subtract these values from these values. 398 minus 7 we get 391. 436 minus 11 we get 425. 542 minus 15. 12 minus 5 7. 3 minus 1 2. 527. Now you can find there their HCF. I have taken here 527 and 425. 425 divided by 527 27. 425 ones are 425. 7 minus 5 2. 2 minus 2 0. 5 minus 4 1. 425. Now it will go on again 4's table. 102 multiplied by 4. 408. 15 minus 8 7 1. Now 102. 17 6 102. We will get here 17 HCF of 425 and 527. Now we have to find HCF of 17 and 391. 17 391. 17 2 is 34. 17 3 is 51. You can see here HCF of all these three numbers is 17. You can find it by prime factorization method or prime factorization method. Same answer will be got by you. Now next question is, express 98 as a product of its prime. Find out factors of 98. 2 4 is 8, 2 9 is 18, 7 7 is 49, 7 1 is 7. We will get factors to multiply 7 raised to power 2. This is your answer. Now next question, if HCF of 408 and 1032 is expressible in the form of this, then find the value of P. For solving this question, we will find first of all HCF 408 and 1032's. 1032 408. 408 2 is 8 2 is 16 and 4 2 is 8. 12 minus 6 6, 2 minus 1 1 and 10 minus 8 2. 408 and it will go on 1. 216. 8 minus 6 2, 10 minus 1 9, 3 minus 2 1. 216. Again it will go on 1. 4. 11 minus 9 2. Now it will go on 8 4 is 32, 8 6 is 16 plus 3. It will go on 8. We find out HCF of 408 or 1032 is 24. HCF of 408 and 1032 is 24. We have to write this value equal to this value. This statement, 1032 multiply 2 plus 408 multiply P is equal to 24. Now here you have to multiply these two values. 4602 plus 408P is equal to 24. 408P is equal to 24 minus 2064. P is equal to minus, you will find here after subtracting this value 04204, that is in the form minus 2040 over 408, and it will be divided by 2040 divided by 408, we will get 5 and P's value is minus 5. Now next question is, find out the LCM of numbers whose prime factorizations are 3 multiply 5 raised to power 2, 3 raised to power 2 and multiply 7 raised to power 2. You can solve it. 3 multiply 5 raised to power 2. LCM of 3 raised to power multiply 7 raised to power 2. You can take here 3 raised to power 2 multiply 5 raised to power 2 multiply 7 raised to power 2. Out of these it will take maximum value common, and then multiply 3 is the 9, 5 5 is the 25, 7 7 is the 49, and after multiplying all these values we will get 11,025. This is your answer. Now next question is HCF and LCM of two numbers. HCF and LCM of two numbers 9 and 459. If one number is 27, find other number. We have given this is HCF and this is LCM. Formula is used here. HCF multiply LCM is equal to sum of two numbers. 9 multiply 459 is equal to one number is given 27, multiply another number we will take as it x1. Now 9 multiply 459 over 27 x is equal to x1. 9 ones the 9, 9 3 is the 27, 3 ones the 3, 3 ones the 3, 3 5 is the 15, 3 3 is the 9. Now you can get second number is 153. And next question. In this question we have to find out x. Find the composite number, that is x. We will start here. 13 5s are 65. We will write here 65. Now we multiply 3 with 65. We will get 195. So that's why when we multiply these two numbers we will get x value. 5, 9 3 is 27 plus 1 8, and 3 1 is 3, 3 plus 2 5. You can see x value is equal to 585. Now next question. In this question we have to prove that 2 plus 3 root 5 is irrational or rational number. Is a rational number or irrational number. For solving this question, first of all, we will write, let us assume to the contrary that 2 plus 3 root 5 is rational. First of all, we will assume that is a rational number. After that, we will write so that we can find integers a and b. B should not be equal to 0 such that 2 plus 3 root 5 is equal to AB is equal to where A and B are co-prime. Sorry, here we have to write A divided by B, and where when we rearrange this equation, we get 2 plus 3 root 5 is equal to 8 by b. After rearranging, 3 root 5 is equal to a by b minus 2 and root 5 is equal to 8 by b minus 2 over 3. Now when we take its LCM, we find it a minus 2b. After this, you can write it like this: a by 3b minus 2 by 3. Now we will write here, because a and b are integers, we get that a over 3b minus 2 over 3 is a rational, and so root 5 is rational. But this contradicts the fact that root 5 is irrational. Irrational. So we conclude that 2 plus 3 root 5 is an irrational number. All questions which are related to this type of question, which will be solved in this way. Now next chapter 2, polynomials. In polynomials, first question, that is, if sum of zeros of the quadratic polynomial is given 3x raised to power 2 minus kx plus 6, that is equal to 3 is given, given what's the value of x. For solving this question, we will write first of all a's value, that is 3, b's value, that is minus k, c's value, that is 6. This is a's value, this will be b's value, this will be c's value. Now put the formula sum of the zeros, that formula is alpha plus beta is equal to minus b over a. Here we will write minus b is k minus k, and c is equal a is equal to 3, and it will be equal to 3, and after this 3 multiply 3 is equal to minus cut with minus k is equal to 9. This is your answer. Now next question, Here you do not write. Now next question is, form a quadratic polynomial whose zeros given 3 plus root 2 and 3 minus root 2. This question will be solved like this. In this question, first of all, you have to write sum of zeros s is equal to sum of zeros s is equal to alpha plus beta, means this is your alpha, this is your beta. 3 plus root 2 plus 3 minus root 2. Root 2 plus root 2 minus root 2 cancel, and 3 plus 3, 6. This is the sum of zeros. Now product of zeros, p is equal to alpha beta. Here 3 plus root 2 multiply 3 minus root 2. 3 multiply 3, 9. 3 multiply root 2 plus 3 root 2. This value multiply this value minus 3 root 2. Then root 2 multiply root 2. We will find minus 2. This will cut with this will, because plus 3 root 2 minus 3 root 2 cancel. 9 minus 2, that is 7. Now you will find out product of zeros, that is 7, and quadratic polynomial is is equal to x raised to power 2. We will use here this formula, x raised to power 2 minus sx plus p. X is square minus s is 6, x, p is 7. This is your answer. Now next question, find the quadratic polynomials, the sum and product of whose zeros are root 3 and 1 root 3. You will solve this question like this. First of all, you have to write sum of zeros, that is given s is equal to root 3. Product of zeros p is equal to 1 by root 3. Now quadratic equation, we will use formula quadratic polynomial. X square minus sx plus p. X is x square minus s is root 3x and p is 1 by root 3. If you want to remove this denominator, then you will take it is equal to 0. Take here LCM, root 3x square minus root 3 multiply root 3, that is 3x plus 1. When we take by cross multiplication, then we will get result root 3x square minus 3x plus 1 equal to 0. This is your answer. Now next question, find the zeros of quadratic polynomial. We have given now quadratic polynomial. We have to find zeros. Root 3x square minus 8x plus 4 root 3. here a is given root 3 you can find out it. There are so many methods. I will take here this method, root 3x square minus separation method, root 3 multiply first of all 4 root 3. This multiply with this we will get 3. Root 3 multiply root 3, that is 3. 4 3 is the 12 and make the factors. 2 6 is the 12, 2 3 is the 6, 3 3 1 is the 3. We have to take those factors which will after adding we will get 8 and multiply 12. Now 3 2 is the 6, 6 or 2 8, 6 plus 2 we will take here factor. Root 3x square minus 6x minus 2x plus 4 root 3. Now you will get here common x and in bracket x root 3 x minus 6. Just a minute. You can take here common 2 root 3 x. When you take this value common, then you will write here no, you can take here root 3 common, root 3x common, x minus here we will take 2 root 3 multiply root 3. When we solve it we will get 6. So we will write here 2 root 3 minus 2 common, then we will get x 2 plus minus minus 2 to the 4 root 3. These two values, these two common factors which we will write in one bracket, and these two factors, common factors, out of these two common factors we will take one common factor x minus 2 root 3. Now we have to find out zeros, so we will write these values equal to zeros like this, x minus 2 root 3 equal 0. When we write these values equal to 0, we will find x value. X is equal to 2 root over 3 over root 3 comma x is equal to 2 root 3. These are the zeros. These are the zeros. Now next question is, if the zeros of polynomials x square p plus px plus q are double in the value to the zeros of 2x raised to power 2 minus 5x minus 3, find the value of p and q. Then we have to find out p's value. For solving this question, First of all, we will write 2x raised to power 2 minus 5x minus 3, and now make its factor 2x square minus 2 3 is a 6. We have to take those two numbers which will add. When these number add, we get 5 and multiply 6, and this number is 6 minus 1. When we minus, we will get 5, and when we multiply we get 6. 2x square minus 6x minus minus plus 1x minus 3. Now take the common value from here. 2x is common, x minus 3 is in bracket, 1 is common, x minus 3 in another bracket, and 2x plus 1 in one bracket, x minus 3 in other bracket. Now take the zeros. 2x plus 1 equal to 0 and x minus 3 equal to 0. We will find x value. X is equal to minus 1 by 2 and x is equal to 3. After this, we have to double, because in question we have given x square plus px plus q are double in the values to zeros. So we will write here, the zeros of required polynomial is double of given polynomial. So we will write here sum of zeros s is equal to alpha plus beta, and alpha is equal to, we will take here 3, that is 3 into 2 6 double, and beta is equal to minus 1 by 2. We will multiply by 2 and minus 1. So here 6 is alpha plus minus 1 is beta. 6 minus 1, that is equal to 5, and product of zeros p is equal to alpha into beta. 6 multiply minus 1, that is minus 6, and you can see its equation, that is x square plus px plus q. X square p is 5x, and q is minus 6. This is your final equation, and you can see as same, p's value 5 and q's value is equal to minus 6. Now next question is, what must be subtracted from the polynomial fx x raised to power 4 plus 2x raised to power 3 minus 13x raised to power 2 minus 12x plus 21, so that resulting polynomial is exactly divisible by this number. For finding subtracted value, we will do this like x raised to power 4 plus 2x raised to power 3 minus 13x raised to power 2 minus 12x plus 21. It will we have to write here in small size so that it can cover on this page all the solution. Minus 12x plus 21, x raised to power 2 minus 4x plus 3. For solving this question, we take here line x raised to power 2 minus 4x plus 3. First of all, we have to make power 4. Then we take x raised to power 2 here. X raised to power 4 because base same, power plus. 4 multiply x raised to power 1 base same, power plus. Plus 3 x raised to power 2. Now here we write x raised to power 2. X raised to power 4 minus 4x raised to power 3 plus 3x raised to power 2. Now change the sign. 6x raised to power 3 minus 16x raised to power 2. Minus minus plus. Minus 12x plus 21. Now x raised to power 2 minus 4x plus 3. Multiply by 6 because we have to find here 6x raised to power 3. 6x we have to multiply 6 by 6x. We will get 6x raised to power 3 minus 24x raised to power 2 plus 18x. Right here 6x raised to power 3 minus 24x raised to power 2 plus 18x. Change the sign. You will get 24 minus 16 8x square. 12 plus 18 minus 30x plus 21. Now you can take here 8x square. 8 4 is the 32 and 8 3 is the 24. Change the sign. You will find finally answer plus 2x minus 3. This is your remainder. This is your remainder value and this is your quotients value. You can see here remainder value 2x minus 3. You can write 2x minus 3 should be subtracted from x raised to power 4 plus 2x raised to power 3 minus 13x raised to power 2 minus 12x plus 21. Now next chapter is pair of linear equations in two variables. First equation, first statement is if ax plus by is equal to a raised to power 2 minus b raised to power 2. Bx plus ay is equal to 0. You have to solve it. We can solve it by adding method. This is your first equation. This is your second equation. First equation add in second equation. We will find a plus b x common, b plus a y common, a square minus b is equal to a square minus b, and you can take here a plus b and a plus b plus a both are same. You can take a plus b is common and x plus y in one bracket is equal to a square minus b square. X plus y is equal to a square minus b square over a plus b. Here you can take a minus b and a plus b over a plus b, and this value cut with this value because same, and a minus b is the answer of x plus y. Now next question, for what value of k the pair of equations 4x minus 3y is equal to 9 second is 2x plus ky is equal to 11 has no solution. When we say there is a no solution, then we will write this formula: a1 over a2 is equal to b1 over b2 not equal to c1 over c2. This formula is used when no solution. And if from first equation we find a1 4, b1 minus 3, c1 is equal to 9, and in second equation we will get a2 2, b2 k, and c2 that is 11. We put first two formulas. 4 by 2 is equal to 3 by k minus 3 by k not equal to 9 by 11. For solving these, for finding k's value, we will solve these two equations by base cross multiplication. We will find 4k is equal to minus 6 and k is equal to minus 6 by 4. 2 2 is 4, 2 3 is 6, minus 3 by 2 is the answer. Now next question है calculate the bounded area by the line 3 x plus y is equal to 10 and both the coordinate axes. For solving this question, we will write first of all equation x plus y is equal to 10. Now let x is equal to 0, then y is equal to 10. Let x is equal to 1, then y is equal to 10 minus 1, that is 9. Thus you can take x is equal to 2, y's value that is 10 minus 2, that is 8, because we can take this equation like this. Now you can draw the graph. This is your table. When you take 0, 1 and 2 and y's value, here y's value 10, here's y's value 9, here's y value 8. You can draw this like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. 0, x and y's value 10. 0, 10. X1, then y's value 9. That is 1, 9. X2, then its value is 8. 2, 8. You can draw